Yo, what's going on guys, Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms, and today's topic is infix to postfix conversion using stack data structure, and more specifically the pseudocode of infix to postfix using stack data structure. So this tutorial is all about understanding the pseudocode because ultimately we are going to use this pseudocode to write a C++ program, or you can use any other general purpose programming language to implement this application of stack data structure, that is infix to postfix conversion. But understanding pseudocode is very important, so that's what we're going to do, and we're also going to dry run this pseudocode that we'll see in a minute now on an example which you can see on the right hand side, and understand line by line every statement of the pseudocode. Now if you've missed the previous tutorial wherein we discussed the different rules which are involved when you have to do the infix to postfix using stack data structure, please make sure you watch the previous tutorial. If you've missed it, you can see all the rules on the left hand side. We even used these rules and solved two examples in the previous tutorial. So this video is taking that video and moving ahead with that. So this is like part 2 of the part 1, that is previous tutorial. And with that being said, let's get started. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks, and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. Now starting off, why do we require this pseudocode of infix to postfix conversion using stack? That is because, as I mentioned, in order to actually implement this application, in order to actually write a program in any general purpose programming language, you require a pseudocode. A pseudocode is sort of like a part English, part code representation of the entire algorithm. So previously we saw all the different rules which was in plain English, which you can right now see on the left hand side. But of course, when you are going to write some program, you need some step-by-step pseudocode kind of syntax which you can easily convert to a code, right? And that's where pseudocode comes into picture. So we're going to use all these rules and create a pseudocode which you can take and implement in any programming language. We are going to use C++ and that would be the next tutorial after this one. But the more important part and the focus of this tutorial, as I mentioned, is the pseudocode. Now before we actually see the pseudocode, we have been given this example. It is a fairly complex example of infix which we have to convert to postfix using stack data structure and using the pseudocode. But before that, let's actually manually do the conversion. We've also seen the manual conversion in previous tutorials in this entire DSA course. So quickly I'm just gonna write this expression, this infix expression over here. And what we'll do is we'll quickly try to manually convert it into postfix. So we have a plus b minus c, which is in brackets. And then we have star d raised to e raised to f. So this is multiple raised to scenarios. We'll talk about it in a minute. It is a unique situation. And then we have divide by g. So it's a fairly complex expression, and the reason I've chosen this is because it will cover pretty much all the rules and all the conditions in the pseudocode as well. So you get a taste of every rule and understand the entire pseudocode thoroughly. But starting off, during the manual conversion, we see the brackets first because brackets has the highest precedence, and the innermost bracket is a plus b minus c. So first things first is this small sub expression will get resolved or will get converted to its postfix format first. So inside this we have two operators, plus and minus, right? And plus and minus have same operator precedence. We've already studied this, and we have to go from left to right when it comes to plus and minus. So a plus b happens first, so we will get ab plus, that is plus will be transferred over here in the postfix format, and then this ab plus will be operand 1, op1, minus this c will be op2, operand 2. So this minus will come over here. So ultimately we will get ab plus and c minus as the postfix format of this small expression. If we consider this as x1, this whole expression will look something like x1 star d raised to e raised to f, then we have a closing bracket, divide by g. Now since we have one more set of brackets, of course this expression has to be evaluated first, and in this expression we have multiple operators. We have two raised to operators, that is exponents, and one multiplication. So exponent obviously has higher priority than the multiplication, so we have to evaluate these two first. Now remember, in the manual conversion in the rules we discussed that when the case of exponent operator comes and when we have multiple exponent operators, we start from right to left. the evaluation or conversion happens from right to left. So first this operator will be converted to postfix. So for this operator the operands are E and F. So this operator will come over here and we will get EF raised to, and then this will be considered as OP1 and we have D raised to. So for this operator, that is the second raised to operator, D is OP1 and this is OP2. So now this raised to will come over here and ultimately we will have DEF raised to and raised to. Now if we were going from left to right, this expression would be something like D raised to E and F raised to. So this is something that we would have ended up, which is not actually correct. The correct version has to be something like DEF raised to. Okay. So ultimately what we are left out with is, let me just erase this out and let's write a shorter version. So we get AB plus C minus star DEF raised to, okay, and divide by G. So this is converted to its proper postfix format. This is converted to its proper postfix format. So we have one last operator, that is multiplication operator, that will come over here and this entire expression will be resolved. So we will get AB plus C. We have minus, this is not 1, it is minus. Then we have DEF raised to and this star will come ahead. And then this entire expression will be divided by G. So this is OP1 and this is OP2 and this is the operator left, so this will come over here. So lastly the final conversion will be AB plus C minus DEF raised to star G and then divide by operator. So this is going to be the final answer, and I know I did it in a little quick way and not so step-by-step way. That's because we've already solved such examples, and when we do the manual conversion, this is what the result is. So let's write this result over here so that later on we can verify it when we are actually gonna convert infix to postfix using stack and using the pseudocode. That's where we can cross verify it. So I'm gonna write the result over here: AB plus C minus DEF raised to, then we have a star, we have G, and then we have divide by. So this is the result that we want when we are gonna actually apply the pseudocode as well onto this same expression. Now I'm gonna erase this out. We've done the manual conversion, and now let's see the pseudocode and let's go step by step. We'll read out the instructions, that is the rules which we've seen in the previous tutorial, and I'm assuming you guys already know, and we will see the corresponding pseudocode statements for those rules, because these rules need to be converted into pseudocode, right? So technically we are just converting these rules into pseudocode format so that we can easily write a program using this pseudocode and using the stack data structure. So let's see the pseudocode now. Okay, so as you can see, it's a fairly lengthy pseudocode, but we will go step by step, line by line, and understand this in very detail. Okay, so starting off, first line says we are creating a function called infix to postfix. So since it's a pseudocode, it is kind of like a code, kind of English statements. So when we convert this to C++ program or any other general purpose programming language, we can create a function which is named as infix to postfix. In that we will pass a stack data structure and we will pass the infix expression. So this entire expression can be stored in a string and it can be named as infix, and it will be passed in this function which is infix to postfix. Okay, so if you consider this as a string, this will be at index position 0, this will be at index position 1, and so on and so forth. So in programmatic terms, this would be a character array, or this can be a string, right, which will have index positions. In C++ we have C style strings and C++ style strings, which we are going to actually use. So this is how programmatically this entire infix expression will look like. It will have index position. So at index position 0 we will have opening bracket, index position 1 we will have another opening bracket, and so on. So the size of this string you can see is from 0 to 16, which is 17, size equals to 17, and it's basically a character array. You can think of it as a character array when thinking in terms of program. So that is going to be passed over here. Okay, now inside this, first things first, we will create a postfix string. We have the infix string which we are going to pass in this function, and then we are going to create a postfix string which will store the postfix expression, that is this expression, and we will build this expression as we entirely run through this entire function. So we'll see how that goes. So after this we have a loop which says I equals to 0 and I less than infix.length. Now infix is basically this entire string. The length of this string is 17. So we want to iterate through all these characters inside this string starting from 0 to 16. So that's why we say I less than infix.length. In our case the length is 17. So we will run from 0 to 16, right? Now this corresponds to the rule number 1 which says scan the expression from left to right. So we will start from left, that is from 0 position, and we will go till the right, correct? So programmatically we are basically gonna go from 0 to 16 from left to right. That's how you scan the entire expression from left to right, right? So first rule pretty much is done over here using this loop from I equals to 0 to infix.length. Okay, now inside this loop we basically have 4 conditions or 4 subparts which I have mentioned by numbers. So this is number 1, number 2, number 3 and number 4. Inside 4 we have more subparts which we will talk about, but in a broad perspective we have 4 different parts. So what are these 4 different parts? Let's read rule number 2 first. The rule number 2 says print operands as they arrive, which means that at any point in the loop when we are iterating from 0 to 16, if the character is a operand is something like a variable or a number or a complex expression can also be considered as an operand, but in our case it is gonna be a variable, right? If a variable happens, that is if A, B, C occurs, it is an operand. So anything that is not a operator or not a bracket is an operand, right, in our case. So if a operand comes, we have to print it as it is. So the first condition, that is the first part, that is point number 1 says if infix of I is an operand, then postfix plus equal to infix of I. What does this mean? This means that if in the infix expression of I, since we are going to go from 0 to 16, at every iteration, if it is an operand, if it is A, B, C, D, E, F or any other operand, you just paste it as it is into the postfix expression. So postfix plus equal to means the postfix variable that we've created over here, let's write it over here. At the bottom you can see I have written postfix. So let's build our expression over here. It will get concatenated every time whenever there is an operand. Okay, so that rule number 2 is basically point number 1 or part number 1. If infix of I is an operand, then just basically put it in the postfix expression that we've created, postfix string that we've created, and lastly we will print this postfix string, right? So at the end of this entire function, in the postfix string we will have the output. Over here in the rules we are just saying print the operands as they arrive. It basically means that just put the operand in the postfix and at the end we are going to print it anyways. So part number 1 or the step number 1 is done, and it is for rule number 2. So this is done now. So operands are done. Operands are basically A, B, C and all the variables, right? So that's done, covered. We've covered operands. The second subpart is for opening brackets. Now remember, in the previous tutorial also when we were going through these rules, we considered opening and closing brackets separately. So we have 3 separate rules for opening, closing brackets, right? So 10, 11 and 12 are dedicated for opening bracket, closing bracket. That's because we do not consider opening bracket and closing bracket as operators. Operators are basically arithmetic operators, plus, minus, divide by, star and raise to. In our example, these are the only operators. So opening and closing brackets are not operators. So for them we have separate rules. That's why we have separate else if condition, which is covered in point number 2 and point number 3. So point number 2 says if infix of I, if the character that we are currently going through is an opening bracket, you just push it onto the stack. So you can see rule number 10, if incoming symbol is an opening bracket, push it onto the stack. So this is covered. So this rule is converted into its appropriate pseudocode over here. So point number 2 is done. Okay, pretty basic enough. Let's move to else if, that is third part. Let me just erase this out. We've done 1, we've done 2, and now we are at third else if. So in the third else if, we are saying else if infix of I is closing bracket. So if it's a closing bracket, then pop and print the stack till the stack gets empty or an opening bracket is found. Now this is corresponding to rule number 11. Rule number 11 says if incoming symbol is a closing bracket, pop the stack and print operators till a opening bracket is found, or obviously the stack gets empty. So that or condition is not mentioned in the rules because the rules are not very specific, because we are not using or we are not writing the code using these rules. But when it comes to pseudocode, it has to cover all the conditions because those conditions are gonna get implemented in the code, right? So when we get a closing bracket, we have to pop and print the stack, that is all the operators in the stack, till the stack gets empty or a opening bracket is found. So this rule number 11 is done. And after we've covered operands, after we've covered opening bracket and closing bracket, the only next symbol, that is the only last symbol left, is the last else if condition, that is fourth part, which deals with operators. So far we covered operands, which is A, B, C and all the variables. We covered opening bracket and closing bracket, but the operators are left. So the fourth part deals with the operators. So in the last else if, that is the outermost else if, we say if infix of I, that is if any of the character is an operator. In that case we have some more extra conditions. So when it comes to operators, we have a lot of more conditions, right? So we have still 3, 4, 5, 6, 7, 8, 9 and 12 rules to be covered. So that's why we have more condition inside this. So let's take a look at what we have. So let's say it is an operator. It is plus or minus or star or divide by or raise to. So in that case we go in the else if part. In the else if part we have more steps. In 4 we have 4.1, 4.2 and then we have 4.2.1, we have 4.2.2, we have 4.2.3, we have 4.2.3.1, which means that we are going inside if and else if conditions, and then we have 4.2.3.2 also. So we'll go through them also step by step and then we will see their corresponding rules in the rules part. So let's say it is an operator, okay? So if it is an operator, we are going to execute step number 4. Inside that we have 4.1. So if it is an operator and if the stack is empty, then we have to push that operator onto the stack. So this is basically rule number 3. If you read the rule number 3, if operator arrives, operator means anything which is plus, minus, star, divide by and raise to, okay? That's what an operator is. So if it is an operator and the stack is empty, you simply push this operator onto the stack. So that's rule number 3. So we've covered rule number 3. Now let's say the stack is not empty, right? So the stack can be filled with other operators also, right? So in that case, we have a else if. So that's why after 4.1, we have 4.2. In 4.2, the condition is the stack is not empty. So let's say the stack is not empty, it already has some operators in it. Now, in that case, what we have to do, we have to check the precedence of the infix of I, that is the operator that we are at currently, with the operator which is inside the stack, okay? So let's say inside the stack we have plus, that is this operator, this is the very first operator, and now minus is coming. So when we are at minus, let me just use another color. So in the operator, let's say we have plus already, and now we are at this position which is minus. So what we have to do, we have to check the precedence, right? We have to check infix of I, that is the precedence of minus with the precedence of already existing top of the stack. So this is the top of the stack currently. So 3 possibilities can happen. The precedence of infix of I, that is this, can be greater than the precedence of the top of the stack, or it can be equal to this. Equal to is a unique case which we will talk about. But let's assume that right now the precedence, let's say we have star coming in, okay? So we are at this position and we have plus inside the stack. So obviously precedence of star is greater than plus operator. So in that case, we will push this star onto the stack. So star will come over here and this will be the new top. So this is basically rule number 4, which says if incoming operator, that is if infix of I, that is this operator, has higher precedence than the top of the stack. Earlier the top of the stack was plus. So if star operator has higher precedence than the plus, in that case we have to push this star onto the stack, right? So this is 4.1.1, which is corresponding to rule number 4. Now in case where the precedence of infix of I is less than or equal to the precedence of the top of the stack, we have 4.2.3.1. But before that, let's say the precedence of infix of I is equal to the precedence of top of the stack, and the operator that we are scanning currently is a raise to operator. Now raise to operator has the highest precedence. Now you can see we are using this precedence function separately. So in the code we will assign precedence to different operators. For example, plus and minus will be given precedence 1. Star and divide by will be given a precedence 2. Raise to will be given a precedence of 3. And whichever has the highest precedence, we will calculate it according to the precedence function. Okay. So that's why I'm using precedence and then brackets and passing the character infix of I. And then I'm also using precedence and passing the top of the stack character to calculate its precedence. And one of these numbers will be returned. Depending upon that, we will calculate the precedence. But here, a unique scenario can happen where infix of I, which can be a raise to sign, and top of the stack can also be a raise to sign. Let's say we have top of the stack as raise to. Let me just do it. Let's say we have top of the stack as raise to, which is going to be the basically first raise to that we put it onto the stack, and now we are scanning this raise to. Of course, when we actually apply this pseudocode on this solved example, we will see that case appears over here. Right now I'm just trying to explain in an overview way. It will be more clear when we actually apply it completely on this expression. So infix of I is also raised to, and top of the stack is also a raised to operator. So the precedence is obviously going to be equal, and the infix of I is a raised to. So the reason why we are having this else if condition, this unique else if condition, is because for the raised to operator, the rule of associativity is from right to left. It's not from left to right, which is there for, plus and minus and star and divide by. It is a unique case. And that's the reason why we get DEF and then we have 2 raised to raised 2's. Otherwise we would get DE raised to and F raised to as the output if we go from left to right. So for that case, we have this unique case that when the precedence is equal and when the infix of I is basically a raised to sign, we simply push the newly coming raised to sign onto the stack. So we will take this raised to and we'll just put it onto the stack, and now this will become the new top of the stack, because we don't want to pop it out immediately. If we pop out the first raised to sign, we will get the result as DE raised to and then F raised to. We don't want that. Okay. And right now it might not be clear, but when we actually apply this entire pseudocode onto our example, things will be more clear. But just understand that this condition is unique for the raise to operator, where we have to push the incoming raise to operator onto the stack if we have the top of the stack as a raise to operator as well. Okay. And lastly, in the else condition, so the first if was when the precedence of infix of I is greater. The second else if was when the precedence of infix of I was equal to, and the infix operator was a raise to sign. So there is an AND clause in between. And obviously the last condition would be when the precedence of infix of I will be less than or equal to the precedence of top of the stack. So in that case, rule number 5 applies. If incoming operator has lower precedence than top of the stack, then pop and print the top. And if you see in rule number 5, it states that if the operator has lower precedence, but in our rule number 4.2.3.1, we also cover the equal to precedence. So let's take an example. Let's say the top of the stack is plus, and now we are scanning, or we are at minus operator in the expression. So infix of I is minus, and minus has equal precedence as plus, right? So top of the stack is plus, and we are scanning infix of I, which is minus. So minus has equal precedence as plus. So in that case, we simply pop and print the stack, and the while condition checks for if stack is not empty. So obviously the plus will be popped out and will be printed in the postfix expression. And once the stack is empty, we have 4.2.3.2 which says push the current operator, which is minus. So minus will be now pushed onto the stack. So plus will be popped out, and then the stack will become empty obviously, and minus will be now the top of the stack. So this pseudocode is slightly different than the rule, but it is pretty much covering this rule also. And that's because in coding perspective, when you're converting an infix to postfix, the operators are basically coming at the end. So ultimately when you pop and print the operators, they will obviously come at the right hand side of those two operands. And you'll see that when we dry run it in a minute. And that is pretty much basically the first iteration. And then we will end the for loop over here after going from 0 to 16. Okay, so 16 iterations obviously are going to happen, and every time either point number 1, point number 2, point number 3 or point number 4 will happen. So either the infix of I, that is the character, will be an operand, it will be an opening bracket or a closing bracket, or it will be an operator. Only 4 cases can happen, and depending upon those 4 cases we have their corresponding actions in the stack data structure. So I just gave you an overview about the pseudocode, and I know things are still not that very clear, and I know it will be very clear only after we actually apply this pseudocode onto our example. So now let's actually do that. Okay, so what I would suggest you guys is to take a pen and paper, and you can dry run this entire pseudocode along with me. You can take a screenshot of this pseudocode. You can, probably pause this video and note down all the points, that is all the rules as well as the pseudocode, because this is very important from your exam perspective as well if the pseudocode is asked. So just take a screenshot, maybe, and take a pen and paper, that is take a pencil and paper, and let's dry run this pseudocode. So first just let's track the I value. So the I value obviously initially will be from 0. So we will go from 0 to 16 in our case. That's the length of the infix expression. This is the entire infix expression. Okay. So initially we will be at position 0. So the loop will start running. We will say if infix of I is an operand. Is it an operand? No, it is not an operand. Bracket is not considered as an operand. Then we will go to step number 2. In the else if we say is the infix of I opening bracket? Yes. What do we have to do? We have to push it onto the stack. So opening bracket will be pushed onto the stack, and this is basically the top of the stack. Since step number 2 is executed, that is this else if part is executed, obviously third else if will not be executed and fourth else if will not be executed. We will come at the end of the for loop, because either of these 4 points will be executed, right? When we are actually writing a code, the if, else if and else control structure works in such a way that only one out of the entire if, else if and else block will be executed. So in our case right now, else if was executed because the character was a opening bracket. So step number 3 and 4 will obviously not be executed. We will come at end of the for loop, and now I will become 1. So I has become 1. We are at this index position. Again we will start with the loop. First is we'll check if this infix of I is an operand. Is this opening bracket an operand? No. Then we will go to step 2, that is second else if. In this else if we check if infix of I is an opening bracket. Yes. So we just have to simply push it onto the stack. So we'll push it onto the stack. This becomes the new top of the stack. And then obviously step 3 and step 4 will not be executed because these are other else if conditions. Only one else if is going to be executed. We will come at end of the loop and we will again go at the start. I will become 2. So at I equals to 2, we are at this index position. Inside that again we will check if infix of I is an operand. And now it is true, right? A is an operand. A is a variable which is considered as an operand. So the rule for operand is print operands as they arrive. And in our case, we will append this A into the postfix expression. So postfix plus equal to means, in coding perspective, it means the existing expression postfix plus infix of I, which means we just want to append it to the existing postfix expression. Right now the existing postfix expression you can see is blank. So the first operand is now appended into the postfix expression. So I'm just gonna write A over here. Okay, so since first if was true, this else if and point number 4 else if will not be executed. Obviously we'll come at the end of the for loop, again go at start of the for loop, and I will become 3. So when I will become 3, we will be at index position 3. At index position 3 we have a operator plus. Okay, so in the conditions, first condition will not be true because it is not an operand. Second condition will not be true because it is not an opening bracket. Even third condition will not be true, it is not a closing bracket. We have a plus sign which is an operator. So ultimately the fourth condition will be true because if infix of I is an operator, which means it can be either plus, minus, star, divide by and raise to. It is plus. So this condition is true. So we'll go inside step number 4. So we have 4.1. In step number 4.1 we check if stack is empty. Is it empty? No, we have 2 elements or 2 symbols which are 2 opening brackets. So stack is not empty. So 4.1 will not be executed. So we will go in the else if part, which is stack is not empty. So in stack is not empty we have 4.2.1, which states that if precedence of infix of I is greater than the precedence of stack of top. Okay, so right now infix of I is plus. What is the top of the stack? Top of the stack is opening brackets. Now according to our rules, obviously we've seen in the theory part, in the rules part, that opening and closing brackets, that is the brackets, has the highest precedence, highest priority. But when we are implementing the code, when we are writing the pseudocode or actually writing a program, these brackets are not operators at all. We are not considering them as operators only. Operators are plus, minus, star, divide by, and this raised to exponent operator. So when we are calculating the precedence of stack of top, which is opening or closing bracket, what we will do is we will give this the lowest precedence, that is the value. So in the code, when we actually write the program, plus and minus will be given precedence of 1, that is the value, that is the weightage. Star and divide by will be given 2, raised to will be given 3, and otherwise in the else part we will return minus 1. So this precedence will be a function which will take a character, and depending upon whether it is plus or minus, star or divide by, or raised to sign, it will return 1, 2 and 3. Otherwise it will return minus 1. So that's how the precedence function will look like when we actually implement the pseudocode. But right now I'm just giving you an overview or a preview of how it would look like. So what will happen? The precedence of stack of top is this opening bracket will be minus 1 because it is not considered as an operator. Precedence of plus and minus will be 1. So 1 is obviously greater than minus 1. So this 4.2.1 will be true, and we will push this infix of I, which is currently infix of 3, which is plus, onto the stack. So plus will be now pushed onto the stack, and now the new top of the stack will be plus. Okay, so I hope you're understanding this. It is slightly different, that is the precedence is slightly confusing, because when it comes to program, when it comes to pseudocode, when you are implementing it, we do not consider opening and closing bracket as operators. These are just used to determine which part of the expression happens first or gets converted first. That's why they are not treated as operators primarily. So now we have a new top of the stack. So since 4.2.1 is executed, obviously 4.2.2, 4.2.3 will not be executed. So we will come outside this inner if. So essentially 4.2 got executed, that is stack is not empty. So this got executed, which means step number 4 got executed. So we've pretty much covered this iteration. Anything else will not be executed. We will come at end of the for loop, that is the outermost for loop. We will go at the top, and now I will become 4. So let's make I equals to 4. So when I becomes 4, we will be at index position 4, which is an operand. So obviously the first part of this pseudocode will be executed. The first part checks if the infix is an operand. Yes, it is an operand. So B will be appended to the postfix expression. Currently the postfix expression only has A. So we will attach B over here. That is because postfix plus equal to of infix of I, which means current postfix value plus this newly added character of infix of I, which is B. So that will be attached over here. Okay. Since point number 1 is executed of the pseudocode, point number 2, 3 and 4 will not be executed. We will come at end of the for loop, and I will now become 5. Now we are at I of 5, which is a minus sign. So let me write minus over here. So this is infix of I, and here I'll write S of top. So it will be easy for us to make the comparisons. So infix of I is minus. Okay. So in the loop, obviously it is not an operand. So first point or instruction number 1 will not be executed. Instruction number 2 will not be executed because infix of I is minus. It is not equal to an opening bracket. It is not equal to a closing bracket as well. So third point will not be executed. So fourth will be executed. Obviously it is for operators, which include minus also. In 4 we have 4.1, which says if stack empty, then push infix of I. Obviously the stack is not empty. You can see 3 operators or 3 symbols, basically 1 operator and 2 opening brackets. So it's not empty. So 4.1 will not be executed. 4.2 will be executed because 4.2 is for stack not empty. So this condition is true. We will go inside 4.2. Inside 4.2 we have 4.2.1, which says if precedence of infix of I is greater than precedence of stack of top. Now infix of I is minus, stack of top is plus. The precedence of both of them is 1 and 1, right? That's what we have deduced over here. So obviously it is not greater, it is equal. So 4.2.1 will not be executed. Let's check for 4.2.2. In the else if, Are the precedences equal? Yes. Precedence of infix of I is equal to precedence of stack of top. 1 is equal to 1. This is true. However, there is one more AND clause and one more condition which says, is this infix of I that we are at, which is minus, is it equal to a raised to sign? Is it an exponent? No. So this becomes false, right? And since there is an AND in between, the entire condition becomes false. So this else if will also not be executed. So we are left with the else block, which is 4.2.3. In the else, obviously, we will say while stack not empty, till the stack is not empty, and the precedence of infix of I is less than equal to precedence of stack of top. Till then, you have to pop and print the stack. That is, you have to pop all the values from the stack and print it into the postfix expression. So pop and print basically means, printing basically means taking out these operators and adding it to the postfix expression. So when we do the first pop, because obviously, what is the condition while stack not empty? Is stack empty? No, we have 3 elements in it. The second condition in the AND clause is infix of I, which is minus. The precedence is it less than or equal to? It is equal to the precedence of stack of top. Stack of top is plus. Their precedence is equal. So this condition is true, this condition is true. So we will go inside the while loop which says then pop and print the stack. So pop. So first thing we will pop this plus sign. It will be popped out and appended to the postfix expression. So let's write plus over here. Let's remove it from the stack. And now the new top of the stack is this opening bracket. So first pop and print is done. Again the while loop will execute because obviously stack is not empty. So this condition is true. However, now when we check the precedence of infix of I is still minus. But now the top of stack is a opening bracket. What is the precedence of opening bracket? Let's write opening bracket over here. The precedence of opening bracket is minus 1 because it is not an operator. So the precedence function will return minus 1. This precedence function will return minus 1. So we will get minus 1. So is the precedence of infix of I, so there is a bracket over here, okay, is precedence of infix of I, which is 1, is 1 less than or equal to minus 1? Is it less than or equal to minus 1? No, it is not less than minus 1, or it is not even equal to minus 1. 1 is not less than minus 1. So this while loop will stop its execution. We will come outside this while loop, that is outside 4.2.3.1, and we have one more statement in 4.2.3 because we are inside 4.2.3, right? Inside 4.2.3 we have a while loop, that is this instruction, and we have one more push instruction. This push instruction says push the current operator onto the stack. Which is the current operator which we are at? We are at infix of I, which is infix of phi, which is minus. So now this minus is taken and pushed onto the stack. So minus will come over here. This will become the new top of the stack. Okay. So we've got minus in the stack. So this is the last instruction in the 4.2.3 else block. We will come outside this else block. We will come outside the 4.2 block. We will come outside the 4 and we will actually go at the end of the loop because we pretty much done all the instructions inside this step number 4, inside 4.2 and inside 4.2.3. So we will come at the end of the for loop. We will come at the start of the for loop and now I will become 6. So I will now point at index position 6, which is a operand. So operand, by now we've understood that we just simply have to print the operand into the postfix expression, which is this condition. If infix of I is an operand, just add it to the postfix expression. So C I'll just write as it is. Let's quickly move forward. Now we are getting a hang of it. Now I will become 7. Now 7 is a closing bracket, right? 7 infix of I is a closing bracket, you can see. So for that we have condition 3. So point number 3 is for closing bracket, which we have got over here, and it says pop and print the stack till the stack gets empty, or a opening bracket is found and then just pop that opening bracket as well. Don't print it, just pop it out. Just remove it because in the postfix expression we are not requiring any opening or closing bracket. So we don't need to print that. When I say print, it means that adding it to the postfix expression. So we've got a closing bracket. We will execute point number 3. Point number 3 says pop and print the stack. What do we have at the top of the stack minus. So minus will be popped first. I'm gonna write minus over here. It is popped out. So now the new top of the stack is this opening bracket, right? The condition says pop and print the stack till the stack gets empty. We have not yet emptied the stack, but the other condition in the OR says or opening bracket is found. So opening bracket is found at the top of the stack. So we can now stop it, but before stopping this else if condition, we have to simply pop this opening bracket out. So I'm gonna just pop it out, which means I'm just gonna erase it and not print it in the postfix expression because we don't require brackets. Now the new top of the stack is this one last opening bracket. Okay. Alright. So far if you've observed, our postfix expression is pretty much exactly the same as the manual expression. So let's move forward. Since this third part is executed, we are done with this iteration. So now I will become 8. I will become 8 and we are at this position, index position 8, which is a star operator. So again, step number 4 will be executed because it is for operators. I'm gonna go a little fast now. In this 4.1 will not be executed, stack is not empty. 4.2 will be executed because stack is not empty. So if stack not empty, 4.2 is executed. In 4.2, we will see the precedence. What is infix of I? Infix of I is star. We are currently at star operator. The precedence of star is 2. So if precedence of infix of I is greater than precedence of stack of top. Stack of top is a opening bracket whose precedence will be -1 according to our custom function that we will create when we actually implement this program. So obviously 4.2.1 will be executed, and in this part we simply push the infix of I, which is a star operator, onto the stack because the precedence of this operator is higher than the current top of stack, which is the opening bracket and has -1 precedence according to our implementation. Hence infix of I will be pushed onto the stack, so star operator will go onto the stack and now it will become the top of the stack. And of course we will come at the end of the for loop, and now I will become 9. So when I will become 9, it is a simple operand. It has to be printed as it is. Let's print D as it is. I'm gonna write D as it is. Let's move forward. When we move forward, we get I equals to 10. Let's make I equals to 10. I'm assuming you guys are also dry running this entire pseudocode with me. That's the best way you can practice and understand the working. So when I will become 10, we are having a raise to operator. So infix of I is a raise to operator. Its precedence is 3. So in the for loop, step number 4 will be executed because it is for operators. In 4.1 will not be executed. That is if stack empty. It is not empty. 4.2 it will be executed because else if stack not empty. Stack is not empty. Obviously you can see stack is not empty. So 4.2.1, what is this? If precedence of infix of I, that is if precedence of raise to operator, which is 3, is greater than precedence of stack of top. What is stack of top? Star. What is its precedence? 2. Is 3 greater than 2? Yes. So 4.2.1 will be executed. Then push the infix of I onto the stack, which means this raise to operator will be directly pushed onto the stack because it has higher precedence than the top of the stack. So now raise to will be pushed onto the stack. This is the new top of the stack. Okay, so we are done with this iteration. I becomes 11. What is at index position 11? We have a simple operand E. E gets printed in the postfix as it is. So directly attach it because point number 1 applies to that, which is if it is operand, then just attach it to the postfix expression. Now I becomes 12, and I'm going a little fast because I'm assuming you guys have got the hang of it. Now we are at I equals to 12, which is another exponent operator. Now let's see what happens, because this is a unique condition. We already have a top of the stack as a raise to operator which has the highest precedence of 3. And now let's see in the loop what happens. So in the loop, in the for loop, obviously point number 1 will not be applicable. It is not an operand, it is an operator. Raise to is an operator. So this will also be not be applicable. The character is not opening bracket, the character is not closing bracket. So step number 4 will be implemented, which is for operators. In 4.1 will not be applicable because it says if stack empty, then push the infix of I onto the stack. But stack is not empty, so 4.1 will not be executed. 4.2 will be implemented. 4.2 says if stack not empty. So if stack not empty, we will go inside this else if, which has multiple steps. Now here we will check if precedence of infix of I. Infix of I, what is infix of I? Infix of 12, which is a exponent operator, is the precedence, which is 3 greater than precedence of stack of top, that is top of stack. What is top of stack? Also a raise to operator. Is 3 greater than 3? No, this is not true. It is equal to 3, but it is not greater, right? So 4.2.1 will not be executed. Let's move ahead in the else if. Let's see 4.2.1. Now here this condition will become matching, which says if precedence is matching, that is infix of I, that is precedence of infix of I is equal to precedence of stack dot top. This is equal, right? This is true. So this is equal. And in the AND clause, the infix of I is a exponent operator. So this is also true, which means else if condition will be executed, which says push the infix of I onto the stack. So we have to take this exponent also and push it onto the stack. So one more raise to operator or exponent operator is pushed onto the stack, and now this becomes the new top of the stack. Okay, so this is the new top of the stack. The reason why we have this unique condition is because, as I mentioned, when we evaluate or when we convert infix to postfix expression which involves two simultaneous raise to operators, in that case we go from right to left and not left to right. So when we go from left to right, we would have literally popped out the existing raise to operator and pushed the current raise to operator onto the stack. But since the associativity of raise to operator is from right to left, we will first push both the raise to operators onto the stack and then pop them out together so that they come side by side, just like we have in the manual conversion. And you'll see that in a minute, and then things will be more clear. Okay, so since this 4.2.2 is executed, we will come outside the entire if else statements. We will come at end of the for loop, and now I will become 13. So when I becomes 13, we have f is a operand. So step number 1 applies. We have to simply paste it or print it in the postfix expression def. Okay, and then I will become 14. I will become 14. So we are at this position, which is now a closing bracket, and now things are gonna pop off, and let's see how things work. So when we get a closing bracket, we come at point number 3. Point number 3 is for closing bracket, right? So if infix of I is a closing bracket, then pop and print the stack till stack gets empty or a opening bracket is found, and pop that opening bracket. So we have to pop and print all the operators till the stack gets empty or we get a opening bracket. So obviously when you're popping, this raise to operator is popped out first. Let's write down raise to over here. So we erased this out and printed it in the postfix expression. So now this is the new top. So this also has to come out because we have to keep on popping and printing till the stack gets empty or a opening bracket is found. Is the opening bracket found at the top? No. So even this is popped out. So we'll write one more raise to symbol over here. This is popped out. Now the new top of the stack is star operator. Is star operator equal to a opening bracket? No. Is the stack empty? No. So we still have to pop this also. So this is also popped out. We'll write star over here and let's erase this out. And now the new top of the stack is a opening bracket. So the condition says pop and print stack till the stack gets empty or a opening bracket is found. And once the opening bracket is found, pop that opening bracket. So we'll simply pop this out, but we will not print it because we are not requiring brackets in our postfix expression. So now our stack has also become empty. Okay. If you see the expression so far, it is exactly same as the manual conversion. We've pretty much got our final answer now. We are left with last 2 characters. So now I will become 15 because step number 3 is done. I will become 15. So we will be at this divide by operator. So since it is an operator, we will go to step number 4 in the loop. In 4.1 will be executed now because if stack empty, then push infix of I onto the stack. Stack is empty, you can see. So this divide by operator, division operator will be pushed onto the stack, and now this will be the new top of the stack. Then we will move forward. I will become 16. 16 is this G. G is a simple operand, so rule number 1 will be applicable. If it is operand, just put it and paste it into the postfix expression. So I'm gonna write G as it is over here. And now we have exhausted the entire infix expression from 0 to 16. We've scanned the expression from left to right. So lastly, when this for loop completely completes executing, that is this entire code, you can see that in stack we have left with the divide by operator as it is. So one last statement will be like just pop and print all the operators remaining in the stack till the stack becomes empty. So that's something that I have not mentioned in this pseudocode, but after this for loop ends over here, there would be one last statement which will basically come after this loop. So after this end for loop, we will have one more instruction which will say pop and print remaining operators from the stack. Okay. So lastly, we will just pop this divide by operator and print it into the postfix expression, and then our stack will become empty. And then our entire pseudocode, entire process will come to a halt. Our entire function will be done. And now if you observe, the manual conversion is exactly equal to the stack conversion using this pseudocode. This means our pseudocode is working perfectly fine. We've pretty much implemented infix to postfix conversion using stack data structure using a pseudocode. So I hope you've understood step by step the entire pseudocode of infix to postfix conversion using stack data structure. And the next obvious video, the next tutorial is to take this entire pseudocode and write a C++ program to implement and to do the practicals of infix to postfix using stack data structure. Now this can be also implemented using any other general purpose programming language because the pseudocode is always going to be the same. The rules are obviously going to be the same. And you can do the practicals using Java or Python or any other general purpose programming language. Okay, so that's it for this video, guys. If you like this video, please give this video a like. Let me know in the comments how this video was, if you watched it so far and understood this entire tutorial. And if you've stuck throughout this video till this point, I would highly appreciate if you can add a comment and give this video a like. And lastly, definitely share this video with your friends. This is an important video. And this is where I'm going to conclude this video. Thanks for watching. See you in the next one. Peace.